Hi guys, in this video we're going to look at how to derive units for Kc. So the units of Kc depend on what is in the Kc expression, and we're going to look at 4 different examples. So Kc, to start off with, is the equilibrium constant, that's the capital K, in terms of concentration. That's what the little c stands for. So when we have a reaction in equilibrium, we can write a Kc expression for it. And what we do is we put products raised to the power of the number of moles over reactants raised to the power of their number of moles. Now, the way we get units is we put the units of concentration, which you know are moles per decimeter cubed, into the equation. So we don't need to use the chemical symbols. I've just written it out here so you can see where I'm getting the things from. So we pop the units of concentration into the expression. So since this is raised to the power 3, we do the same with the units. Moles per decimeter cubed over moles per decimeter cubed squared. And then we cancel. So this divided by this. Now, since we've got 3 lots of this on top and 2 on the bottom, 2 of these cancel with 2 of these to leave 1 lot of moles per decimeter cubed on top. So the units this time come out as moles per decimeter cubed. In our second example, we've got moles per decimeter cubed squared, because we've got 2 lots of the product on top, and then for the reactants we've got 4 moles altogether, so it's moles per decimeter cubed to the power 4. So these 2 cancel with 2 out of the 4 of these, and we're left with 2 moles per decimeter cubed on the bottom. So we have to raise this to the top. It's on the bottom at the moment. We need to move it up. At the moment, moles would be moles squared because you've got the 2 outside the bracket. When we move it to the top, it changes its sign. So change sides, change sign. It becomes moles minus 2. And the same thing with the decimeter cubed part of the unit as well. So at the moment, it's decimeter minus 6 because we've got the 2 outside the bracket. And minus 3 times 2 is minus 6. When we raise it to the top, it becomes decimeters plus 6. In our third example, we've got 1 mole of product, so 1 lot of moles per decimeter cubed on the top, and we've got 2 moles of reactants, so moles per decimeter cubed squared on the bottom. So this cancels with 1 of these to leave 1 lot of this left over on the bottom. So at the moment it's moles plus 1. We move it to the top, it becomes moles minus 1. Down there it's decimeter minus 3. We move it to the top, it becomes decimeter plus 3, but we don't need to write that plus. And then the last example illustrates that Kc doesn't always have units. They can completely cancel out. So if we've got equal number of moles on both sides, 2 on the right, the product side, 2 on the left, the reactant side, you can see that they cancel out to give no units.